Hello class, and welcome to arithmetic time. Now, today is a review lesson. So if you go to Schoology and see your assignment for today, it's a review lesson, but we're just going to go over a few things, maybe a few shapes and a little bit of geometry, and also a few of the word problems, story problems. I want to bring those up too to make sure we've got the right idea of it. All right, so look here. What is this? You say line segments. You said that. Good job. What is that? Point. Did you say point? A point. If it's with numbers, it's a decimal point. But it could, in geometry, a point or vertex type thing we'll be discussing not today, but at some point. Then look, line. Line. It has the arrows on the end. Did you shout it out and say it, Michael? Did you say it, Alice? Did you say it, Naomi? Did you say it, Skylar? All right, everyone? Nick, did you say it too? Everyone? Emma? And what is that? Yes, if you said angle, you are correct, which is two rays put together. A ray is just the point with the arrow on the end, and you put two together to make an angle. What is that? That is an angle, but more specifically, what kind of angle? Did you say a right angle? You are correct. If you said a right angle, it makes a perfect square there. Did you say angle? What kind of angle? Now there's two of them. So in relation to each other, they are called what? Remember what we said? If the angle there is the same, we call them congruent or congruent angles. That's right. Oops, go back the other way. What are these lines doing? They are what? Just dropped my pointer, excuse me. They are intersecting, intersecting. Got this here. This is perpendicular to that. And that's why we say this is perpendicular to that. That is perpendicular to this. All right? And if you look, there's two right angles. It's forming two right angles, whether it goes straight through or whether it stops there. It's still forming two right angles, a right angle here and a right angle there. And so we call them perpendicular. How about those lines? What are they? Did you say parallel? Did you say parallel? You are correct. Good job. They're running right beside each other and they never intersect. Now, what shape is that? Of course, I hope you knew that that is a square. Good job. Okay. Square. And of course, that's right, triangle. Now, for this one here, there's nothing here. What shape is it? That's right. This card is in the shape of a rectangle. If you said rectangle, give yourself a pat on the back. How about this one here? What is this called? Now here's a clue. These lines are parallel and these lines are parallel. They're running the same direction at the same angle. So it's called a parallelogram. A parallelogram has parallel lines this way and parallel lines that way. It's a parallelogram. Not to be confused with this. Wait a second. What's the difference? What's the difference? What is this one called? Who said rhombus? If you said rhombus, raise your hand. Rhombus is correct. The difference is a rhombus has all equal lengths. There's two parallel lines. There's two parallel. It is a parallelogram. but more specifically, what kind of parallelogram? A rhombus. All the lengths are equal, whereas just a parallelogram could be various lengths. You know, one side may be longer than the other on a parallelogram, generically used, meaning just a more broad term. But this is more specific. A rhombus. Looks like a diamond. You pointed that way, doesn't it? Twinkle, twinkle, little star. Okay, like a diamond, okay, in the sky. Now we're going to go over some word problems or story problems. If you look at section, you like that? It's upside down, right? Do you like that? I don't know why, but that always seems to happen for some reason. But that's all right. We got it. Look, 4A. What coins? In story problem 4A, I wanted to show you something so that you do it correctly. Okay. Now, we've got in our word problem or story problem something going on where you've got $20, your total cost is $18.97, and it asks you a question. It asks you what coins. So it doesn't just say, how much would you get back? I think all of you could do that. Oh yeah, I'll just subtract and get the change, right? And that's true. But it's asking what coins would you receive. So I want you to think about it like this. $18.97, I give them a $20 bill. How much more would make $19? Oh, well, three more pennies will make $19. Okay, and then once I'm at $19, how much more would make $20? Oh, well, $1. That's not hard, is it? $1. So I'm at $18.97. 3 pennies would make 19, and then from 19 would be $1. So, and I know I'm giving the answer away, but with me, are you with me? Are you watching? It's asking you what coins. So I'm going to say, well, Mr. Doyle, I'm going to give them, or I'm going to receive 3 pennies, and I'm going to receive a $1 bill. And I'm going to write 3 pennies and $1 bill. I'm not just going to write $1.03. No, I'm going to say 1 penny and write out the word penny and $1 bill. And what we're doing is we're trying to get you to think that way, that when I give them a $20 bill, I know I'm getting 3 pennies back and $1 bill, because that is what they will give you. You see? And so don't just write $1.03. Write 1 penny, because, I'm sorry, write 3 pennies, because it would be 3 pennies to get you to 19. And then how much more to get to 20? $1. And so it's really good for your brain to think this way. Now, in your next story problem, you will have a 10-inch candle that's burning. Think of the candle burning. And every half hour, it burns 3/4 of an inch, 3/4 of an inch every half hour. All right, well, that's half an hour. It's burning for 4 hours. How much? I believe it asked you something like, how much did it burn, or how much of the candle was burned after 4 hours, something like that. And I'll have to look down in the book, but all right, that's what you've got to know. All right, well, what am I going to do? I want to multiply 3/4 times 2. Why did I say 3/4 times 2? 3/4 of an inch every half hour. We want to get how much it would burn in 1 hour so that we can figure out how much is burned in 4 hours, right? So first we've got to know how much would it burn in 1 hour and think through this. Well, how many half hours are there in an hour? There's 2, right? There's 2 halves to make a whole, right? So if we multiply logically, if we multiply times 2, we'll get how much it burned in 1 hour. If it's 3/4 inch in a half hour, right? Well, how much would it burn in 1 hour? See? Well, that brings us to the next one. The next little card here, I wrote it in steps. We're going to multiply times 2 to get what it would be in 1 hour. Maybe you need to cancel as you multiply. Then once we get how many inches it would burn in 1 hour, what do we have to do? We would logically multiply by 4 to get how many it would get in 4 hours. Because remember, we have to multiply because each hour it's going to get bigger, right? And we multiply to get that number that many times, right? 1 hour, then 2 hours, then 3 hours, then 4 hours, that many times. So multiply times, and that will get you the correct answer. So you do those. Here are the steps. Welcome to watch this video again. This is not a long video. I just wanted to review some things for you since it is a review page, and do it. And you can do it and do a super job. Actually, most of you do a super job in arithmetic class, and we actually need a little more help with our language, it seems. So you take care, and you do a super job. And again, I'll be looking for you in the next video. Bye-bye.